making sense of fraction operations provides you a way of helping learners make sense of comparing, adding, subtracting, multiplying, and dividing fractions in ways that utilize visualization as the representation, that help them conceptualize the very different strategies that are used for doing the computations. For the purposes of example, we are going to use the two fractions 2/3 and 3/5, but I'm going to contextualize these in the form of two classrooms. Miss Red and Mr. Blue both teach 3rd or 4th grade children, and their students are having a little trouble making sense of the fraction operations. So they decided that they would both bring in a large pancake, not pancake, a large cake in a pan, exactly the same size for the red class as the blue class. And after giving the children each equivalent pieces of the cake, Miss Red noticed that she had 2/3 of a cake left, where Mr. Blue had 3/5. So let's take a look at how these two fractions can be compared, and in the sense of which is greater or which is less, and also how much less and how much altogether. Do we still have maybe enough cake to go around? Okay, so let's take a look at how we might draw these two cakes. So the first pan looked like this, and the second pan is the same size, so we pretty much draw a pan the same size. In the first pan, I'm going to mark off the 2/3 using horizontal markings, and I'm going to zigzag the parts that represent the 1/3 and the 2/3. Does that make sense? In the blue class, the cake was divided into fifths. So let's do these vertically where the others were done horizontally. Okay, I haven't made them exactly equal, but I think you get the idea. So we need to zigzag 3 strips to show 3/5 of the cake was left. So in Miss Red's class, 1/3 of the cake was eaten, and in Mr. Blue's class, 2/5 were eaten, so this is what remains. Okay, so what I'm going to do is reproduce the blue pattern on the red cake and the red pattern on the blue cake so that you can see there's an equivalent way of being able to represent them. So I'm not having to color in anything anymore. I'm simply putting in the 5 columns that would have been on the blue cake and the 3 rows that would have been on the red cake. Does this make sense? So if we look at the quantity that is left, which I have marked off in black over here on both cakes, I think we can see that the 2/3 is equivalent to 2 rows of 5, which is 10, out of what would have been 3 rows of 15. And the blue cake, we have 3 columns of 3, which is 9 pieces, out of what would have been 5 columns of 3, which is 15. So we now have established equivalent size pieces, each of which is 1/15 of the original cake. And I think we can easily see that the red cake is a bit more than the blue cake because I can count 10 pieces here, and I can only count 9 over here. So if I matched them pair for pair, there would be 1 left over on the red. So we can say that the red left over is greater than the blue, and we can also show how much greater by pairwise removal or straightforward subtraction. So 2/3 minus 3/5, and if I had room below the screen, I would write it there, but I'm just going to do it alongside because I think you get this. And this is, the difference is 1/15. And if we marked off all 9 pieces, I think you would see that there is one left over here and the others all would be removed. Okay, now we want to look at the operation of addition. How much do we have altogether if we combine both classes' leftovers? So we're taking 2/3 here and we're combining it with the 3/5 from the blue class. And we know that that is the same as 5/15 and, not 5/15, 10/15 and 9/15. So let's see what happens. If I take each of these, I see I have room for 5 over here. So if I take 5 from here, this group of 5, and I move them into those spaces, I will end up with one entire cake, and then there's a little bit left over, which is this over here, which is equivalent to 4/15. And if you go back to the version of adding 10/15 and 9/15, we could say this is the same as 19/15. And if you divide that out, it does equal to that. So now we have a way of visually showing the common denominator 15 that works for thirds and fifths. So now our big issue is multiplication. So let's move to a clean page and we'll see how to work that out. To make sense of multiplication, at this point, children should have a good sense of using the array model for multiplication of whole numbers. So let's go ahead and take advantage of that as we think about using the array model for fractions. So I'm going to go ahead and I'm going to draw one whole cake, the red cake. But I know that I only have 2/3 of it. So this is the section that corresponds to the 2/3. And really what we're looking at in the length here is 2/3 of 1 unit. I'm going to superimpose the fifths. And I'm going to mark off the 3 columns of fifths. And these are represented here. Okay, so the area that represents 2/3 of the 3/5 is the marked off area. So if you think about each of these columns being the entire 3/5 of the leftover blue class, and I needed to do 2/3 of that because multiplication corresponds to an of. Even if that's not clearly understood, there it is. So we're looking at how much of the total unit is 2/3 times 3/5. So it turns out to be these 6 parts out of what would have been 15/15. So all we're doing then is multiplying the 2 numerators, 2 times 3, and the 2 denominators, 3 times 5, to get the 6/15. I'm not so concerned with simplifying this at this point. That can come a little later, but the main thing is to get the concept of multiplication as a length times width construct. Okay, so now we need to deal with the concept of division and how we do this. For the life of me, I cannot explain why when we take 2/3 and we divide by 3/5 that we have to find the reciprocal or the flip of one of the numbers and then multiply. So I know the one has to do with multiplication, but why this works is what we really need to make sense of. So both teachers decided that the student who did the best in their class was going to get a special prize at the end of the week, which was to take home a portion of the cake equivalent to the smallest one, which we now know was the 3/5, which happens to be 9/15. But in the red class, we have 10/15. So let's make sure that we rewrite these things exactly as we had them before on the drawing. Okay, so this is the winning prize. This is the size of the winning prize, which is 9 pieces, where the other class had 10 pieces left. So it looks like we can give one prize of 9 pieces in the red class and one prize of 9 pieces in the blue class too. So what is the meaning of this remainder, this one single piece that's remaining? Could we give it as a second prize? And how much of the original portion would it represent? So what we have done is we've taken 2/3 and we've divided it into however many portions, 3/5 in size, we would get, and we end up with one entire portion and then one part of the 9 that we would have liked to get. So let's make sense of this using our old algorithm, which told us to take 2/3 and multiply by the reciprocal, which is 5/3. And we just learned how to multiply. So this gives us 2 times 5 is 10/9, which I believe is 1 1/9. Let's look at this another way. We have 2/3 is 10/15, and we're dividing by 3/5, which is 9/15. Well, if we do straight across like we did with multiplication, we'd have 10 divided by 9 on the numerator, and the denominator would be 15 divided by 15, which is a 1. And I think from the whole number work that we have done, or that the students will have done at this point, if we have, say, 23 and we divide by 1, we end up with 23. So in the same sense, 10/9 divided by 9 is just the 10/9. It doesn't matter what the number is in the numerator. If you divide by 1, you get the same thing. And so it works. Okay, so let's take a look at how this would look if we did it the other way around. Finally, the last thing I want to do is look at how 3/5 divided by 2/3 means multiply by 3/2 gives us 9/10.